Here we go again. Today we're going to talk about how atoms bond. Last time we talked about how atoms each have different energy shells and the number of electrons in each one of those energy shells and how we found that. And specifically when it comes to bonds, we're going to talk about the valence electrons, which are the electrons in the outermost layer of the atom. So what we need to do is we got to figure out how many electrons are in that outer layer. Well, let's use oxygen as an example. Let's go back to the periodic table. We see that oxygen is in the second row, so therefore it has two energy shells, or electron shells, and that it is in the sixth column, therefore it has 6 electrons in that second energy or electron shell. So in the most electrons that can fit in that second electron shell are 8, and oxygen only has 6. Therefore it needs to borrow 2 more electrons from somewhere, and usually oxygen travels in pairs, so therefore it's like it has a double bond usually between 2 oxygen atoms. But in water, H2O, 2 hydrogens donate an electron to that outer layer, making the oxygen more stable, and that's how water is formed. I'm thirsty. Another example would be sodium and chlorine. For example, sodium has 3 energy levels and it has a 1 electron in that outer level. Since sodium has 1 electron in the outer layer, it's easier for it to donate 1 electron than add 17 electrons to fill up the outer shell, because in the third energy level it can hold up to 18 electrons. But it only has 1, so it's easier to give up an atom versus take on 18 different electrons from another atom. That electron is actually going to get taken and donated to another atom. This is another bond I'm using as an example. And it's going to donate to chlorine. Also has 3 energy levels, but has 7 electrons in that outer energy level, so it easily borrows an electron from sodium. And that's how you get sodium chloride, or table salt. Here's a picture of them being bonded together. So what happens is sodium donates an electron to chlorine, and then they become bonded together, creating an ionic bond. Ionic bond is basically when an atom donates one of its electrons to another atom to fill its outer shell. In this case, sodium is donating an electron to chlorine, creating table salt. And tonight's assignment, you're going to create some bonds of your own. But before you get started, we have to talk about one more thing: covalent bonds. Unlike salt, an example of an ionic bond, covalent bonds are usually bonds between 2 non-metals, usually gases, with similar electronegativities. So what happens is atoms share electrons in their outer orbitals, but don't really have that strong of a bond. We've already kind of talked about one of these again, water. Thirsty again. Anyways, whatever I had for lunch is making me thirsty. Usually covalent bonds are usually gases or liquids, and they don't have a very strong bond because when they can be separated pretty easily. Just a small amount of electricity through water, it actually breaks the bond of oxygen and hydrogen. That's how we produce a lot of our hydrogen gas and oxygen gas in an industrial setting. For homework, yeah, sorry. show a few of these types of bonds. And basically what I'm going to do is I'm going to give you two or three atoms. I'm going to draw a picture of how those bond. But remember, you got to satisfy one thing. And most atoms need 8 electrons around them in order to create a bond. And except for hydrogen, where you only need 2. That's the only element where you need. The first example we're going to talk about for your homework is hydrogen peroxide. It is H2O2, which is 2 hydrogens, 2 oxygens. Yeah, it sounds like water, but it's actually not. Hydrogen peroxide's usually used for cleaning wounds or cuts. There's 2 oxygen atoms. We need to figure out a way that they bond with those 2 hydrogen atoms in order to put 8 electrons around both those oxygens and 2 electrons around both those hydrogens. And that's a basic covalent bond. And how we're going to do that, I'm going to show you. First, the chemical formula for hydrogen peroxide is H2O2. The formula looks like. So all I want you to do for your assignment is draw lines between those 4 elements to show the bonds between them. And so you got to connect them in an order that shows that they're sharing electrons. And that's kind of a little bit confusing, I know. What the drawing for hydrogen peroxide looks like is this. Let me zoom in here for you. It's pretty basic, but you need them connected to the right elements. What that means is we know oxygen usually travels in pairs, so they're going to bond with each other. But they also need one more atom to fill that 8 electrons on the outer shell on each one of those oxygens. They're kind of sharing one electron between each other. So they need to fill that outer shell with one more electron. So you're going to add a hydrogen onto both of those. And that's just one example. What I'm going to do is I'm going to give you the chemical formula of H2O2. And then you'd give me a drawing like this. Before we talk about our next example, I want to show you how those electrons satisfy each one of the elements to make it a stable molecule. We know hydrogens have to have 2 in their outer shell. The oxygen is sharing one of its electrons with hydrogen. And we know the octet around the oxygens is fulfilled because it has 8 electrons. An octet means just an atom has 8 electrons in its outer shell to make sure it's stable. It's sharing 1 electron with the other oxygen and 1 electron with the other hydrogen. And this oxygen is also fulfilling its octet by sharing that 1 electron with the other oxygen and 1 electron with the other hydrogen. And this hydrogen is all set because it has 2 electrons around it. And this is called a Lewis structure. A Lewis structure just shows how many electrons an element has around its atom to show you how they bond. Before I go on to the next example, I would actually like to say that all these examples are part of your homework, so I'd pay attention. These are like basically free answers. And remember, you're going to actually just have to draw a molecule just using lines and the chemical symbols, which is just the letter. The next example is actually an interesting one. It's methane. I think it's interesting because the biggest source of methane is flatulence in our country. Cow poop. In other words, cow farting or cow poop. Yep, methane. And the chemical formula for methane is CH4, meaning it has 1 carbon atom and 4 hydrogen atoms. And the reason we know carbon has 4 electrons in its outer shell, we look at the periodic table again, and we go from 1 to, skip the transition metals, 3, 4, where carbon is. So that means it's in the 4th column. That means it has 4 electrons on its outer shell, meaning you need to fulfill that octet rule, meaning it needs 4 more electrons to fill that outer shell of carbon, giving it 8 electrons. It's going to get those 4 electrons from the 4 hydrogens that it's with. And your drawing when you're done should look like this. The next example I'm going to talk to you today is also an example on your homework. Wink, wink, hint, hint. Anyway, it is called hydrogen cyanide, which is, well, it's a poison. So it can kill you if you have it in large quantities. There's actually in a lot of foods. Apricots and almonds. You actually eat it in low doses, which doesn't even like bother you. But if you have it in high amounts, yeah, enough can kill you. Anyway, the chemical formula for cyanide is HCN, hydrogen, carbon, and nitrogen. And we already know that hydrogen has one electron around it. And we already know that carbon has 4 electrons around it. But we don't know how many electrons nitrogen has around it. So we're going to have to go back to the periodic table again. Periodic table, how do we find the number of electrons in this outer shell? What we need to do is start over here, nitrogen is. So that's 1, 2, we could skip the transition metals, 3, 4, 5. We now know it has 5 electrons in the outer shell. And how many electrons do we need to fill our octet rule for nitrogen? 8. So we gotta find 3 more electrons. That's pretty easy. But what we need to do, since our formula is HCN, we gotta connect those somehow. Nitrogen shares 3 electrons with carbon, that helps carbon out. And then carbon fills the octet around nitrogen. But carbon needs 1 more to fill that octet around it. Remember, hydrogen only needs 2. So your drawing is going to look like this. Carbon is going to share 3 with nitrogen. So you're going to draw 3 bonds between carbon and nitrogen, just 3 lines. Since carbon needs 1 more electron, you're going to show a bond between the carbon and the hydrogen. And the Lewis dot structure between them looks like this. So hydrogen has its 2 electrons, so it's satisfied. Carbon is sharing 3 electrons with nitrogen, so it's satisfied. And plus it has the 1 over here, so that's 8 around it. And since carbon is sharing 3 with nitrogen, and nitrogen already has 5, that satisfies the 8 around nitrogen. That's the Lewis dot structure, hydrogen cyanide, which is, again, very dangerous. So the next thing, I'm going to send you the homework. In the homework, it looks like this. We already did hydrogen peroxide. All we're going to do is draw what the molecule looks like just by showing those bonds between the elements. So H2O2, remember, was 2 H's and 2 oxygens. The drawing for that one looked like this. That's hydrogen peroxide. And then we did methane gas, which was CH4, so it's going to be a carbon with 4 hydrogens around it. And that one looked like this. And then we had hydrogen cyanide. And I'm going to show how many bonds are between each of those elements in that molecule. And what you're going to do, try drawing them. Then you Google the drawing for each of these if you need to. But I want you to try it first before you give up. If you really can't figure it out, look for it. And remember, you got to set octet rule. Each element has to have 8 electrons around it to make it stable and make it part of a molecule. You're going to show that with your bonds. And that will be your homework for tonight. But in the meantime, what's that noise? There's something weird going on outside. I'm going to check it out. Oh my God!